is about the productivity. So these are the outlines of the presentation. Today we will discuss about the introduction of the production function and the stata. By using stata, we can estimate the productivity, or we can analyze the production function by using the stata. So today we will discuss about the production function and the use of stata to analyze the production function. Okay. For simplicity, I have used Cobb-Douglas production function, which is given by Charles Cobb and Paul Douglas in between 1927 to 47. So this Cobb-Douglas production function is the technological relationship between two or more independent variables and one dependent variable, that is output. So in any industry, there may be some production of items, and the production of items this variable. Okay. So this is the simple, which is widely used production function, and this is the functional form of the this Cobb-Douglas production function. And this y means your output variable. This y is the output variable, and this fx means the function of excise. Excise means the inputs. Okay. So input may be your labor, or input may be your capital. Okay. So this is the functional form of the Cobb-Douglas production function. And after taking logarithm, we can make it linear. So after taking logarithm, we can make it linear. So this is the product of excise raised to the power beta j's, and this a is the total factor productivity, and this xj is the input variable. Okay, there are more than two input variables, so this xj denotes the number of inputs variable. X1 means first input variable, x2 means second input variable, and this beta j is the coefficient of elasticity. Okay, that tells about the how much is the input variable effect on the output variable. So after taking the logarithm, this equation becomes this type of equation, that is the linear equation. Okay, after taking logarithm. So product, as we know, the logarithm is the monotonic function. Okay, monotonic means have you heard about the monotonicity? Monotonic means if your x variable is say increasing, okay, but after taking logarithm, it will again increasing, it will not change. Okay, so that is the monotonicity. That's why we are taking logarithm over here. So these are the this beta note is the log of a. A means your total factor productivity, and this beta j's, other beta j's are the output elasticity of the inputs and the labors. These xi's are the labor and capital inputs, or it may be anything. It may be, for example, we will discuss the production of milk. Then the number of kettles is your input variable. Okay, number of say this for example, say the number of hours that we use to take the production of the milk. These are the input variables only. Okay, so these are the xi only. And y is the total production, that is the real value based on the input variables. Okay, and this so in this function, how the inefficiency is occurred. So in Cobb-Douglas function, this is the Cobb-Douglas function, y is equal to f of x, and this mu is the factor of inefficiency. Okay, in the next lectures we will discuss about the inefficiency. So this is the mu is the factor of inefficiency. So how to measure the inefficiency using Cobb-Douglas production function, we will discuss it later. And this is the form of the functional form of the Cobb-Douglas function with the output oriented inefficiency. Okay, so there are two types of inefficiency, output oriented or input oriented. So this is the form of Cobb-Douglas function in case of output oriented efficiency. So this is the production function with the input oriented inefficiency. Okay, and this is the functional form of the production function in case of inefficiency. And these are the some other production functions. We can also use these production functions. And today we will discuss about the Cobb-Douglas function and the analysis of Cobb-Douglas function in stata. So now we will discuss how to open the stata, how to enter the data in stata, how to generate variables in stata, okay, and how to analyze the Cobb-Douglas function in stata. So this is the first window. When we open the stata, we get this window, and after, if we import the say any file, for example Cobb-Douglas function, say for example we have some production file, so we can click on open button. Okay, then this window will appear, and from here we can select that particular data that we want to analyze. So this is the dairy data as given by sir. So we will discuss about this data, and the next step, and after clicking OK, these are the variables which are included in that particular data. This first variable Ly means log of yield production, or you can say y is the yield production. Then len means log of len size. So these are the variables which are included in that particular file. Okay, then how to check these variables? So simply click on this editor button, we'll get the variables and with their values. Okay, so this is the first variable, this Ly, these are the productions. Okay, so we have already told that the production function, Cobb-Douglas production function, is linear in logarithmic form. That's why we have already taken the logarithm of all the values. So this is the yield in logarithmic form, and this is the land size, this is the labor, this is the feed, this is the number of cattle, and this is means IT expenditure as a percentage of whole expenditure. Okay, so from here we can check the values of each and every variable. The next is how to run the Cobb-Douglas function. Our first step is to check the summary of the data. So we can simply click on statistics. Okay, then you will get this window. Then click on summarize, and then summary and descriptive statistics. When you click on this, there is a summary statistics. Okay, and the next window will appear. This is the summary. In this, we have the number of observations in the data. Okay, this is the mean of each and every variable, and this is the standard deviation, that is minimum value, and that is the maximum value. So in this way we can find the descriptive statistics of the variables, or simply you can write a command sum for a summary. Okay, and these are the variables for which we want to get the summary. So there is a command, sum command in Stata for getting the summary of the variables, or you can simply click on text and then go for a summary. There are two ways. One is tab based, other is code based, command based. Okay. So for cooperative exclusion function, this is the first step. The click on statistics and then linear model and related. Then click on linear regression. Why linear regression? Because we have converted all the variables in linear by taking logarithm. Okay. So click on linear regression. You will get this window. In this window, you have to select your dependent variable and your independent variables. So click on this. You will get the list of the variables. From here, you can select your dependent variable, and from this you can select your independent variables. Okay. So after clicking on OK, you will get this window, and this is the analysis, or you can say the regression of the given data. So this has three parts. One is this one. This part is the ANOVA table. Okay, analysis of variation. Analysis of variation means that variation in the output variable. Okay, how the variation is divided. ANOVA means analysis of variation. Variation means variation may be due to independent variables or may be due to some random error. So this table shows the variation due to model. Model means due to independent variables, and this is the residual. Residual means an error which is beyond human control. Okay, so this tells about the variation beyond human control, or variation that is not explained by the independent variables, you can say. Okay, amount of variability which is not explained by the these independent variables. That means some more independent variables are there which can be used to analyze the model and to increase the find the correlation of another variable with the output variable. If correlation is more, then you can enter that variable in the model. Okay. So, and this is the f value. The f value means f value tells about the significance of the model. If this value, if this f value, this is the calculated f value by the model, and we can check this value. We can calculated value based on this model, and we can compare this value with the critical value from the F table. Then we can find is it significance or not. So first step in any model is to check the overall significance of the model. So overall significance, to check the overall significance, there are two ways. One way is to compare this value with the critical value. Another is the p-value. This is the p-value, and this p-value must be less than 0.05 if your level of significance is 5%. If your level of significance is 1%, then you have to check with the 0.01. So first step is to check this value. We have to compare this value with the level of significance value, and this value, if this value is less than level of significance, means your overall model is significant. Then go for next step to check whether which one variable is significantly affect the output after getting this significant. Otherwise, there is no use of the model. Okay. So next is this means this R square. This R square is the
correlation.
No, R square is not correlation. R square is the coefficient of determination, or you can say the variation explained by independent variables. Independent variable means how much variation is explained by these selected independent variables in the dependent variable. Okay, so this much is the amount of variation explained by independent variables under consideration in the dependent variable. So this is the 87%. So that means our model is good. Okay, this is the goodness of the model. If this mostly this value may be greater than 0.75, well, means there is a lower bound that we can say that this model is good or not. That is the 0.75%. Around 75% we can say that the model is good. So first step is to check this overall significance of the model, and second step is to check the R square value. But in this case, if we have more than two independent variables, then we have to check for the adjusted R square. Okay, this R square will be checked if your simple linear regression model is there. Means one output variable, one input variable. Then you have to check simply R square value. Okay, and if we have more than two independent variables, then you have to check adjusted R square. Okay, and this is the root mean square error. Root mean square error means xi minus x bar whole square, means deviation, sum of deviations. Mean square error means mean square errors. First find the errors, means predicted value and the original value, their difference, then s means square, then square of all the values, and then their mean. Mean means sum of all the values divided by number of values, and then their root. That is your root mean square value. It should be minimum.
Last point again.
This one. How to find root mean square value? Root mean square value means first we have to find the error term. How to find the error term? Error means actual value and the predicted value. This model gives us the predicted value based on this model, and we have some original value for that particular value. Na? So take difference between original value and the predicted value. You will get the error. Okay. So first find the error for each and every data. First value there is error. Second value there is error. Third value there is some error. Okay, and then their squares. You can find your squares. First value square, second square, third square, fourth square, and then their mean. How to find mean? Sum of all the
Observations.
squared observations. Okay, and divided by how many observations are there. Simply you can find the mean and then take their root. Okay, square root. You will get the root mean square value. That this root mean square value should be minimum. Okay, and after getting the significance of the model and this goodness of the model, okay, this R square, adjusted R square value, then you have to check for each and every variable. If this is not significant, then there is no need of this one. Okay, if this model is significant, then you have to go for a second step. And this is the these are the coefficients, you can say betas. Okay, these are the betas, and this is the standard error, this is t value, this is p value, this is the 95% confidence interval. So this L lang means the first variable is the logarithm of length size. This means this positive means there is a positive impact of length size on production of milk. But whether this effect is significant or not, you have to check from here. This should be less than 0.05 if your level of significance is 5%. So you have to check this significance of this variable from here. But this you can see that this is not the significant value. Means there is a positive impact of length size, but it is not significantly affect the production of milk. Okay. Then second, labor. So this is the beta, okay, corresponding to labor, and this is the p value. This p value tells the significant. Means this labor size is significantly affect the milk production of milk. Labor size, if we increase the labor size, means if we increase 1 unit in labor size, you will get 13% increase in the milk production. Okay, this is the interpretation of this coefficient. First check whether this coefficient is significant or not, then check the value of that particular coefficient. If this value is positive, that means there is a positive impact on the output variable, and if this is negative, then there is a negative impact on the output. Here output is a production of milk. Okay. So now the third is a feed. So feed is also positive and significant. Means if 1 unit change in feed, for example, unit is say kg. So 1 kg, if we increase 1 kg of feed, we will increase the production of milk by 17%. And the most of the effect you can check the number of cattle. Means if number of cows are increased, then 75% of the milk production will increase. Okay. Okay. And this comp means the variable IT expenditure is a negative impact, but not significant. Okay, not significant means if we increase on IT expenditure, so there is no effect of this IT expenditure on the milk production. Okay, if this value is not significant, this value is not significant, that means there is no significant impact on the milk production. Okay, so this is the simple co-production function using stata. Now we will do it by, these are the slides.
I have a question. Sir, ये जो variable है IT expenditure, is it relevant in this context? मतलब जिस बारे में हम बात कर रहे हैं, वो IT expenditure हम
Relevant नहीं
इसीलिए
है।
लिया था हमने, ये चेक भी करते हैं उसको।
ठीक है।
हाँ। So if you have any doubt in this summary, how to open this data, how to enter the data in stata, and how to run co-production function in stata, and how to take the logarithm of these values. Okay, so screen यार,
Jadid,
चलिए।
can you please help?
मतलब क्या difference है इसमें देखो stata में मतलब हम क्यों
कोड बेस्ड है ये ना, अभी बताता हूँ आपको। As any variable, there is a z value which is the standard value. Z means normal distribution. So you can take that value minus their mean divided by standard deviation. You will get the standardized value. You will get the standardized values. Okay. After getting the standardized values, if you run the regression, you will get the standardized coefficients. Okay. And now.
They always say that I don't understand why one should be using a standardized regression, because what you are doing is the scale, change the scale of the variables, right? So your x may be, I mean, I give an example that one of the x variable may be elephant, the other one is an ant, right? So you don't want to put them side by side because one is too big, the other one is too small. When you standardize, like ants become elephant or elephant becomes ant. So everything is kind of in a scale for which mean is 0 and the variance is 1. Right? So they are more or less homogeneous. Other than that, there is no gain in terms of running the standardized regression. So I don't do that. And again, if you check in a textbook in econometrics, you won't find any discussion of standardized regression. Maybe that people in finance do that type of thing, but not in economics, because we don't see any benefit of doing that. Basically showing you how to run a regression using stata, but that regression can be done in any software, even in Excel. Okay, but the reason we are using stata is that while stata and R and some other software can estimate the stochastic frontier model. Okay, I don't think that Excel can do stochastic frontier model, but I don't use those type of things. Again, like Excel is, I mean, I cannot move when the mouse too fast to do that. I prefer typing the commands and things like that.
SPSS.
Well, I don't think SPSS has stochastic frontier. No.
So it is also used to visualize patterns or data and manage.
Yeah, no. Again, there are hundreds of different softwares that can be used to run regression.
Yes, sir.
But again, we are not talking about running a regression. We are talking about estimating efficiency. And there are only few softwares that are designed to estimate a stochastic frontier model. So one is again like stata, the other one is R, and then you can use SAS. Are you familiar with SAS? This is what I used when I was a graduate student. And then, I mean, these are the only softwares that I know that can be used to run stochastic frontiers. But you can always do a Google search. That the softwares that can estimate stochastic frontier models. Nowadays everybody uses R because this is something that you should all do it because this is kind of investment. And again, when you look for a job and you say, well, you know R, that gives you an additional advantage because now the companies are also getting to R because it's kind of a free software, and the others are not free. You have to buy them.
Thank you, sir.
Okay, so that is you can buy.
Stenta, and how to enter the data or how to open the file. So simply click on open, and then this is the file, daily file given by sir, and these are the variables in the right side. These are the variables, and to check these variables, click on this button, data editor. Okay, you will get the list of the variables. Okay, and simply click on close button. You will return to this window. And if you want to find the logarithm of the any variable, so simply gen, a command gen.
So that's not for generate or simply G.
There is a variable com. Let's see here.
chair side में तो
Is it visible? So simply gen command generate or as such said G command and the variable name that you want, then equal to and log logarithm of which variable, that is say comp variable. So simply click on this, you will get the logarithm of this variable, and this is the log of comp means a new variable with a log transformation, and you can check this variable to click here. After clicking here, you will get that variable which we have recently generated. Okay, so that's this is the process. You can generate all the variables in a logarithmic form, and if you use this as this command based, this is the command SUM sum command, and simply you can enter, you will get the summary of all the variables, or you can write sum and you can select the variables one by one. For example, this y variable, then length variable, labor variable, how many variables you want to select, you can select here. Okay, so simply click enter, you will get the summary of all the variables, okay, that you have selected. And for regression, there is a regress command. Regress, simply write regress, 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 then space, then dependent variable followed by independent variable. Simply click on dependent variable and then one by one click on independent variables. Okay, and then simply click on enter. You will get the now this is the analysis, or you can say the regression. Okay, so these are the commands which we can use to regress the output based on some independent variable. So now I would like to invite some of the students that they can use the Stata and to check how to run the data, how to generate new variable, okay, in logarithmic form. And then if you have any doubt, we will discuss the same.
chair can you put the shift the chair from
You can simply use the tab commands also. Go to statistics. Then click on summary.
बैठ के कर सकते हैं आप
Then click on summary and descriptive. Left side. Left side. Here is a summary statistics. Now select the variables from drop down button. No. From drop down. Summary statistics. Okay. Now from drop down button, from this, you can select the variables. Click those variables for which you want to get the summary, and then click OK. Click OK. You will get the summary of the selected variables only. Okay, and you can run the regression also. The linear models. Go to linear models. And the linear regression. Then select the dependent variable from drop down. From here, you can select. No. First select the dependent variable. These are the independent variables, huh?
Left hand.
Select dependent variable, that is Ly, and these are the independent variables. Simply click on OK button. You will get the regression.
in the independent variable you insert the dependent variable as well in the previous slide.
Okay. You can run again. Huh? Simply click on this and then get linear regression. Next question. So this is how we can run the regression using Stata. Okay. So anyone who want to run
Just how to enter the data from how to
okay, how to enter the data? If you want to check how to enter the data from your desktop to Stata, you can try.
Just a second. Are any one of you are doing research and you have your own data set that you want to experiment with?
Have you any?
No? Okay, so that would give you an exposure to how to import the data from Excel. So you have the data in Excel, and again, the Stata has that option that when you can export the data from Excel to Stata. Because again, the data has to be in some form, not some, but you don't, nowadays you don't type.
Stata? Paid, yes, paid. Stata is paid. It is not free software.
Yeah, unless you get it from a friend or there are other ways of doing it. But yeah, it's not something that's free. R is free.
Sir, can you discuss
And-
about confidential interval?
Yes. This is confidential. This is the 95% confidence interval. Means if we run 100 times that particular model, 95% of the values, 95% times the actual value, the real mean value, lies between these two variables. Lies between these two values. Means there are 5% chances that our actual mean is beyond these two limits. That is 95% confident. We are 95% confident that our actual mean lies between these two limits. Actual mean means this is a labor, and this summary statistics you see the summary statistics there is a mean column. That mean lies between these two values. Okay, but here is the coefficient. This confidence interval for these coefficients. Okay, confidence interval may be for mean values or maybe for these coefficients. So here this 95% confidence interval is for these coefficients only. So we are 95% confident that this coefficient lies between these two values.
Okay, can you elaborate on this degree of freedom?
Degree of freedom is the number of variables which are independent, or you can say, for example, we have in this column we have 4 degrees of freedom.
Yes.
Then how much are the independent variables are there? 1, 2, 3, 4 and 5. Sorry, there are 1, 2, 3, 4. No.
No, you have to include the intercept also, so 5.
Yes, five variables. No?
Okay, 5 variables.
So that's why this is the 4 degree of freedom. N minus 1 is the degree of freedom. How many values are there? 196 values are there, and the total degree of freedom is 195. Means number of observations minus 1. Okay, and this is 191 means the total minus this model degree of freedom. This is the error degree of freedom. Okay, we have independent. How many independent choices we have? For example, we have 3 values and sum should be 10. We have 3 values and sum should be 10. So how many independent entries we have? We can enter any value. Only 2 values are independently we can enter. Third is based on that the sum should be 10. So we have 2 degree of freedom in case of 3 values. Okay.
So another way of saying is that our degrees of freedom is equal to the number of observations minus the number of parameters you estimate. So in a way that I always say that, okay, this is what you have to start with, and then you pay for each parameter you estimate. So if you start with 195 rupees, you have to pay 1 rupee for each parameter you estimate. So the degree of freedom is whatever is left after you pay for the parameter estimates. Now, again, like we can discuss these things, but I think it would be better if you start with the stochastic frontier model and then you can continue, because this is a standard regression model. And you can ask me after, I mean, when we start after the lunch. I mean, this type of things I can also do, because he is doing it for, I mean, how to use SCADA, and then he's doing it in his laptop. I don't do it. I have my laptop, I can use it, but it's too complicated. Okay, so let's just.